Hello and welcome everyone to a new week of this study season program at TE Academy. Welcome back to live track number 5, on-chain analytics for token engineers 101, token engineers. Become a do-your-own research maxi from scratch using ChatGPT. And we again have a session with Roderick McKinley. Welcome again, and welcome everyone in the call. Before we start, I'd like to share some announcements that I don't want you to miss. First, in case you are following us via YouTube, LinkedIn, or Twitter, you can get full access to all the learning materials here, and you can have the chance still to mint an NFT as proof of knowledge acquired in this live track with Roderick if you register at tokenengineering.net to the study season. Then we'll share all the links, all the recordings, and anything you have to know to mint an NFT. On top of that, I'd like to make you aware of an event we'll run tomorrow, the Future of Crypto Impact Measurement. We've invited our friends at Methodical, at Hypercerts, and open source observers. They are all active in the sector of measuring impact in crypto economies, as we are. And since we are launching a new update of our course reputation-based, NFT-based reputation in Web3 tomorrow, and we'll share some more updates of what we have been working on when it comes to make reputation and knowledge count in our own economy. We think this is going to be a great event for everyone interested in how can we quantify impact and value added to our economies. This is sometimes, not sometimes, it's a real challenge. I think all the communities and projects we've invited provide some really interesting, exciting solutions. We certainly will discuss challenges that still remain, and I hope we'll have a great conversation. Make sure to register and join us tomorrow, June 4th, at 3 p.m. UTC, and the QR code provides you with the link to register. Then I just wanted to give you a heads up. This is the last week of Roderick McKinley's course on-chain analytics, and we'll share later after the session more details about how to receive this NFT. You will have to submit a homework. This homework will be graded, and the links where to submit and all the deadlines, when to submit, when to receive the results will be shared later in the session. Just to let you know. Okay, that's it from my side. I stop sharing and hand over to you, Roderick. Welcome back, and thanks for having you in the session.
Awesome. Thanks for having me once again. And hello, everybody. Let me just start the share, hopefully without gremlins. Give me a second. Cover screen up?
Yes. All good?
Okay. We're ready, people. So welcome to day 3, where we're finally going to get to use ChatGPT to write a subsequent code for Dune and learn how to do that safely and reliably. If you're just joining now for the first time and you enjoy what you see here, I'm an active content creator as well as a consultant. So do feel free to connect with me on any of these other channels that you can see on the screen right now. Okay, so the session outline for today: brief recap of day 2, review and discussion of the day 2 data challenge, understanding Uniswap event tables properly, looking at quirks and common pitfalls of our data, and using ChatGPT to code reliably, as well as an intro to the homework to earn your NFT as a proof of knowledge and accomplishment by working through a demo of 2 worked examples. So let's go. First of all, on-chain analytics. We're reviewing the session material from the previous session. And this term is pretty broad, right? It encompasses raw data that's human readable, decoded data that's readable, but is either cast at the blockchain level or associated and filtered down at project level. And then we have transformed data, which perform some kind of operations on that lower data to improve it or make it more understandable or surface some insight. Now, lots of tools and services are available, and they're differentiated around data performance, low versus high level data, open and closed processes for analysis, and an orientation on behavioral analytics or analytics more focused on financial and economic metrics. Now, we saw that query platforms are special because they give us the power to ask any question that the data itself allows. A lot of analytics work is not about coding skill, but about understanding your data. It is impossible to use Dune without understanding its data. And luckily, there are lots of resources that you have available to teach yourself how to do that. You have the Dune Data Explorer, the Dune Community, Dune Docs, the documentation from the project that you're examining, internet research, and you can also use ChatGPT, although I caution you to be very careful when you're using it this way. And we got a question in the last session about exporting data from Dune, and I'd said that it was only available on paid plans, but that's not quite true. CSV exports are limited to paid plans, but you can get API exports on the free plan, which is kind of funny because that's a more powerful way of getting the data out. I haven't played around with the free tier export, so I don't have a sense of how quickly this capacity constraint comes down to bite. But you can get data out on the free tier if you're savvy enough to do that through an API. Okay, so as you saw from the session outlook, today we're going to do a complete, clean, and thorough documentation of all the Uniswap v2 event tables on Dune. Now, I can do this confidently because I already did some of that grittier work that I introduced you to in the previous session. And I asked all of you to have a go at doing this all the same, even though we're going to go through it properly today, because I wanted you to get acquainted with all those sources and methods that we walked through and to prompt you into thinking a little more actively about this data. So as a challenge, I gave you this list of tables and invited you to start documenting their variables, their column names for yourself. And we're going to reveal the answers today because we really need them. This understanding will help us think of interesting questions, guide us to be able to express our questions clearly to ChatGPT and to critically assess what ChatGPT sends back. And there was a minor error in the prices table that I got you to look at, but nothing that will make a big difference. And I've also added this additional token ERC20 table because I realized that the queries that ChatGPT was sending back were too intensive working with a larger prices table. So this smaller table will help us with some of that. So let's start off with the decoded tables in green, because understanding these ones first will make clear why we need the curated data tables as well. Zappy recap of the AMM exchange. This has been created to allow users to swap between a single fixed pair of tokens. And this requires us to have reserves of both tokens provided to us by other parties, the liquidity providers. And LPs are free to withdraw their tokens in proportion to their original deposit. If we think about this for a second in a bare bones, abstract sort of way, the smart contract has to handle three events: a swap, people adding liquidity, and people withdrawing liquidity. This simple understanding already covers the majority of the decoded event tables. Those are the three events there, matched to each of their tables. But before the AMM gets to do any of that, it has to be created. And since something which doesn't exist can't exist to create itself, in computer science at least, we're going to need another contract to create the AMM pool for us. And that's called the factory contract. So let's look at that first. And we've got the Data Explorer view open on that table and its column headers. Now, on the right here, we have a sample from the official Uniswap entry for this event. And this is the only event that this contract, the factory contract, emits. As I was looking around, I also found another great source, which wasn't included in the previous session. The Ethereum Foundation has published some excellent documentation, which is more compact and continuous and maybe an easier read. So you've got the details of that source on screen now. Anyway, back to the factory contract. This exists just to create liquidity pools. Every pool is defined by its capacity to swap between a specified pair of ERC20 tokens. And every pool pair is unique on the Uniswap V2 protocol. So duplicate protocols are not allowed to exist. You can't have a wrapped ETH, two wrapped ETH USDC pools. It just wouldn't be permitted to create another pool with that same pair. And that's being done by design to prevent fragmentation of liquidity and to prevent vampire attacks on established pools. This Solidity pair created event logs critical information associated with this act. And we're going to step through that now. First off, we have contract address, which reports the address of the contract which creates the pool, which is the factory contract. And in pair, we have the address of the pool which has been created. This is the address of the contract that people will go to do the swapping, liquidity provisioning, and so on. So let me let you in on a mildly embarrassing story here. I came back to work on this table after a while spent working with many others, and I was trying to replicate some results that I'd already gotten earlier, and I just couldn't do it. This table was only giving me results for a single liquidity pool, and I couldn't work out for the life of me what was going wrong. And since I'd gotten this data before, I assumed something was wrong, and I sent a slightly irritated email to Dune support, only to realize that I wasn't looking for pool information in the contract address field, which in this table context is only going to show one result because it's reporting the address for the factory contract, not the address of the AMM liquidity pair. In other table contexts, this field, contract address, does report the address of the pool, but not here, okay? So be really careful not to get these mixed up. It happens to a lot of people. There's only going to be one result in that field. So stepping through the rest of these column headers, event transaction hash is the unique hash which identifies the transaction, and event block number is the number of the block in which this transaction occurs. Event block time is the time the block is committed to the blockchain, and event index is the order in which the event is processed in that block, and it starts counting at 0. It's 0 indexed, okay? And I just did a quick query so you can check that the bottom bound is 0 there. And then we have token 0, which is the address of one of the tokens in that pair, and token 1, which is the address of the second token in the pair. And these are sorted by default. So, you'll have alphanumeric sorting on the address string, and whichever one is lower is put automatically into token 0, and the one which comes after it is allocated to token 1. This last parameter is actually unnamed, so it just has this _0 label, and it just counts how many contracts have been created. And I checked that was the case with a little mini query that calculates the cumulative total and then compares it to that number as well. Okay, so that's the factory event pair contract pair created table done. And remember, this is the only event that's defined for the factory smart contract. So now it's time to start looking at events that are emitted by the pair contract, which is the contract which governs the behavior of this liquidity pool that the factory contract created. Now in this table, contract address does refer to the address of the pool, okay? And these other variables are the same as before. Sender reports the address that initiated the swap, and 2 reports the address of the swap counterparty, which is the counterparty that's going to be receiving it, that's involved with all of this motion of tokens going in and out of the smart contract. And note that when these are the same, the person initiating is also the swap counterparty. And the reason why we allow these to be different is that this foundation enables us to set up routing through multiple pools with the help of router contracts, okay? And finally, we have the amount of tokens going in and the amount of tokens going out. These are counted and tracked this way to avoid the use of signed integers. Mark explains the reasons for this in his first liquidity math lecture, and it's about allowing for better memory efficiency. Okay, next up are the events which handle the adding and removing of liquidity, the mint and burn events. Let's start off with the mint table first. Contract address, again, refers to the pool that's involved. Other variables are the same. Sender address is the address of the sender that is depositing liquidity, and there's no flexibility for a separate address in this case. And we have the amounts of token 0 and token 1 deposited in amount 0 and amount 1. And burn is almost exactly the same, right? The contract address is the address of the pool again. Other variables, same as before. Sender is the address which initiates the withdrawal request. We do allow for the possibility to have a separate recipient again. And again, the amounts of token 1, 0, and 1 being returned by the smart contract in those fields there. Okay, so that's almost all of the decoded tables apart from the sync table. And the best way to understand this event is as the means which the smart contract is using to do some internal accounting. Because when tokens are paid out for liquidity withdrawals, the proportion of tokens that the liquidity provider receives will depend on the balance of tokens that are in the pools, and those are changed by the actions of swappers. Likewise, the price that are given to swappers depends on the pool balance, which is affected by liquidity deposits and withdrawals. So this sync event is used to update reserve balances after all these events so that the correct token amounts are calculated for the next action. And again, contract address is the address of the pool that's doing the syncing. These guys, same again. And we now have reserve 0 and reserve 1. And to denote the balance of tokens in these pools, and note that these are balance or stock concepts, not flow concepts, as we've been dealing with in the amount and in-out fields that we were looking at before. So you need to handle them appropriately in your calculations. So that's the view of the decoded tables. And hopefully this kind of raises some interest or curiosity in appreciating how the needs and constraints of implementation in actual code end up giving a specific shape to an economic process that you might otherwise have been imagining slightly differently, because in your mind, you can entertain this process in some kind of pure abstract and simple way. But in code, you know, these other things come in and force you to express that slightly differently. The remaining tables that we're going to walk through now are the curated data tables, which already represent some kind of abstract notion that we find intuitive or coherent. In this case, we're dealing with really simple and familiar concepts. Starting off with the token ERC table, ERC20 table. This contains information about ERC20 tokens, right, which is the standard token format in smart chains that use the Ethereum virtual machine that work with Solidity, right? So blockchain records what blockchain the token is on, because that ERC20 token can exist on multiple EVM blockchains. Contract address now refers to the address of the ERC20 token, okay? Context matters, okay? Here we're talking about the token address. And symbol contains the text for the token symbol, and note that it's not always available. And decimals contains the number of decimals the native token units are adjusted by in order to be displayed to users in the format that they find familiar. And this needs some explaining. So Solidity and EVM do not support fractional token amounts. Whole numbers are used in all the calculations. The decimals field is used to adjust that number to display fractional amounts to users. But under the hood, the protocol is continuing to transact and do calculations with whole number units. This is what you see in the untransformed data. To transform the base or raw units into display units, you have to divide the base number by 10 raised to the power of the value in the decimals field. So for example, if decimals has a value of 6 and the transfer is of 1,000 units in a Solidity base, this will be seen by users as a transfer of 1 token. Now, if no value is specified in the decimals field when the contract is created, the default value for decimals is 18. However, the value that's recorded in the decimals field is still a null, and that creates a little bit of extra detail that we need to consider when we handle this variable. So, yeah, as I just said, if no value is supplied, we'll get a value of null. And to get around this, to actually put in a value of 18 when we're making those base adjustments, we need to use a function called coalesce, which is designed to return the first non-null value in a list of arguments that you supply to the function. So by setting a constant non-null value as the last argument, we're effectively setting a default return value for this function. So we see on here is an example, amount 0 divided by power of 10 raised to coalesce, the value we get in decimals, but if it's null, use the value 18, okay? Next, we have the prices USD table, which has all the same field names as token CRC20, but contains 2 extra fields. We have price and minute. These specify the USD price for a given token specified in the contract address at a given minute in time. Now, the reason why we're using a separate token CRC20 table is that the addition of these price minute data makes this prices USD table much, much larger. And that means that the queries that use this table will generally be slower. So it's better practice for us to use the smaller ERC20 table if we don't need that data. And we could actually get ChatGPT to do that, make those adjustments, but then we have to give it extra instructions because it wouldn't understand that context, those requirements up front. And given that we have this really easy option to use the smaller table, that's not optimal. So let's just work with 2 tables. Not all tokens will have USD prices. And furthermore, while it's very tempting to get excited and think, oh, wow, we have USD prices, let's just merge them in and use them in a casual and straightforward way, using USD prices actually brings in several subtle issues and implications, which can turn out to be important in certain analytical contexts. So it's best to take a good look at them now. We're habituated to think of currencies as money, as something that has its own intrinsic worth, and we use it as the basis to measure the value of other assets by. And that's fair and reasonable, right? This is one of the core utilities that currencies offer us. So when we go to one shop and we see a computer for $500, and then we go to one next door, which has the same computer listed for $600, we think of the second shop as being more expensive. Not that something has happened to the value of our currency that makes it less valuable in the second shop. And if you're laughing, it shows just how powerful a grip that default frame has on our thinking. For those of us who never had any prior experience as market traders, we tend to apply the same mental model that we have for currencies to tokens and cryptocurrencies. The name didn't help, of course, but in this context, it is grossly inaccurate to do that. For these assets, if we walk into a different shop and receive a different price, it may well be that our tokens are worth less in that shop, except that, now we're not really talking about shops, we're talking about exchange markets. Since no crypto asset has features that put it on par with our off-chain fiat currencies, whenever we talk about crypto asset prices, it's always in the context of a price that we get in some specific exchange market. And so when we start handling and working with prices in our analytics work, it will often be necessary to keep in mind, or at least check in to note which market price we are working with and analyzing, because the same crypto asset will have different prices in different markets, and sometimes those differences matter. Now, the reason why we need a separate table for USD prices is that for the time being, no USD price is ever defined in a local AMM market context. An AMM pool is created to offer a swap service between a specific pair of digital assets, and since there is no blockchain native dollar issuance that is 100% fungible and equivalent to its off-chain counterpart, there is no AMM pool that gives you a direct market price in US dollars. So when we bring in a USD price, it is a US dollar price for the asset in question that is provided by a different market, or perhaps an average of some number of them. Related to this, stable coins are not dollars. There are tons of risks associated with them that the US dollar does not have, and including risks associated, and this includes risks associated with exchanging them for their face value. If you're using USDC pools to give you a dollar price in your AMM swaps, your results are going to be off for those weeks around the Silicon Valley Bank crisis last year. The other consequence of all this is that in order to carry out this value analysis in dollar terms, we're going to have to blend in off-chain data, because dollars are exclusively off-chain money and currency instruments, and the centralized exchanges have their own order book systems for generating and completing those trades. Okay. Yes. So sometimes the market price we want to focus on is the one that's internal to the AMM, even if that's not natively denominated in true US dollars. And when we do that, there's some things to note in this area as well. So suppose we are going to use the factory contract to create a new pool for a new asset. Obviously, we have to give it the address of the new token that we're creating this pool for. But then we have to provide the address of a second token that we're going to set as its pair. Now, that could be any ERC token out there, ERC20 token out there, but that's not going to be economically rational to choose that token pair randomly, because the typical motivation for someone opening a pool is to offer token holders a doorway to financial liquidity, ultimately in their own preferred currency asset. But seeing as fiat assets are not available natively on a blockchain, the digital assets with the best properties for that objective are going to be those which have deep and liquid markets, and multiple markets, preferably, that you can show up to trade them, and do so without your sale making too much of a dent on the price. So that pair you choose is sometimes called the quote or reference asset, and it has these superior liquidity properties. And as you might guess, a lot of people will come to the same view of what those assets should be, and there's some sort of like reinforcing network effects. And this recurring reliance on the most liquid pairs creates a foundation which allows AMMs to be networked together to facilitate swaps between any assets, usually routing through one of these dominant liquidity pairs. Now, I couldn't find a diagram illustrating the flows for DEXs specifically, but this Sankey diagram illustrates flows and conversions through key pairs in a different trading context, which illustrates the idea. Now, all of this ties back to USD pricing, because if you want to bring a USD basis into your AMM price analysis, it's probably going to be more accurate to do that through the asset which serves as the quote or reference asset in this particular pair. Okay, we also have more technical issues to pay attention to. Remember that the units of that Solidity handles to represent token quantities are integers, and they are typed as integers in the data. In many forms of SQL, including Trino, if you divide two integers, you're going to get the integer part for the result only, with the remainder or the decimal part excluded. What you need to do to get around this is you need to retype the variables before you divide them, and you do that using the cast function as shown. And there are a number of data types you could use, but double works fine. And you also need to handle or distinguish between the Solidity basis and the decimal format. And you need to be clear which price you're talking about. Is it A over B or B over A? And the way to handle this is with careful naming. Personally, I like to use a underscore raw suffix to distinguish quantities that are defined in the Solidity basis, and use price A from B to label prices, because this intuitively mirrors the ratio. This price A from B has the A first and the B second, which it matches the way I read a ratio as having the A on top and the B underneath. Now, some people prefer B to A, so maybe you find that easier to think with, but whatever you do, be consistent with your choice, okay? It's no fun working through code, and you'll confuse yourself if it's one way sometimes and the other times. And just a quick reminder that when you are adjusting prices from raw into decimal form, there are lots of ways that you can express the basis adjustment. So all of these expressions are mathematically equivalent, and that might also take that into account if you're looking at other people's code, of course. And it's super important you keep an eagle eye out on which price you're calculating, whether it's A over B or B over A, because as you can see, that also affects the way you can express this basis adjustment in the math. And also, another point, when you're aggregating, the order of operations will impact your results. So the example I've given here is that the daily average of the ratio of both quantities at minute level will not be equal to the ratio of the daily averages of those quantities, right? Now, there's no hard, fast rule about what you're supposed to do in these situations. Different choices are appropriate in different circumstances, but just be mindful and deliberate with what you choose to do. Also, in some cases, you will want to identify or label the asset in the pair that is being used as the reference asset or liquidity asset. And doing that will make it easier to create calculations where this economic distinction is meaningful and be able to do that without always having to remember whether that token is token 0 or token 1. And you can do that using the case statement to make a conditional value assignment to a field that's meaningfully labeled as shown there. Just be aware that this example does not handle a situation where both are liquid assets or neither of them are. You'll need to decide what needs to be done in those situations according to your specific study or situation. And finally, sometimes no events occur on a given time interval. And that can lead us to end up with tables which have gaps in the dates. The dates just don't exist, when we might otherwise actually want a table that has a complete list of dates and report 0 in the other fields that we're tracking. The way to get around this is to create a table with a date sequence, and you can see an example of code used to do that here. And then once we have this table defined, at the point once we want to sort of like join it all together to a date line, we join our calculated data to this continuous date line, and that way we don't have this problem. Okay, so that's a complete account of the tables and a bunch of conceptual and technical issues that you'll need to keep in mind while working with them. We're about to move on to the ChatGPT part, and this will involve using some of the information we've been discussing. So I want to check in briefly and see if anybody has any questions at this point.
We had one in the chat. I think we have solved it. This was where to find the actual token name. When I only have the symbol, could go to use the contract name and go to a platform like CoinGecko. Maybe there, I guess there are plenty of other methods.
Well, we have
go.
If the symbol exists in the token CRC table, then you look up the symbol and then you get the contract address, right? There's no directionality on these tables. These tables have, by design, they associate all the relevant, all the matched data points within the same table. So yeah, you can go that, or if you're already in a Dune environment, if you're already interacting with these tables, you could query it that way.
Other questions on what we have just discussed? I think it's super. I'm really glad we went over these details that perfectly complement what we are discussing in track 3. So yeah, just keeping in mind that the on-chain data is not what we usually expect when it comes to accounting USD values, and we have to handle this and transform it so that we can further analyze it.
Yeah, it's worth mentioning that doing this work brings you a step closer to the smart contract engineers, right?
Absolutely.
Because you start thinking how they do, and that can actually, I mean, it can end up putting you in a position where you're able to collaborate profitably as an economics designer or engineer, because you then start having some sense of what they have to work with and how you can you'll be able to read some of the code they send back. So this is a very sort of small stepping stone that gets you a little closer there. So there are lots of benefits that come with this work. Okay, if we have no further questions on this, I'll proceed.
Okay, and everyone, feel free to drop questions in the chat so that we are aware of it. Happy to make time for it. And yeah, I want everybody to be able to follow and ask questions anytime.
Okay, the screen back on? Angela, is the screen back on?
We are now looking at the last slide you just shared. Is this the one
Okay,
you want
fantastic.
to
Data
continue with?
challenge
Okay.
with the big tick. Yeah, thank you
With the
so
big
much.
tick.
Okay, now I want to start by offering some general thoughts about ChatGPT's performance in different contexts, because they vary in ways that seem puzzling, right? Actually, I just want to make clear that we're only just beginning to talk about ChatGPT now, and I use that as a hook to draw you into this course. But it isn't that I've deferred doing so until very late. It's because this is how you prepare yourself to work with ChatGPT. If you want to work with a current generation of tools reliably, the key to achieving that is understanding your data through and through. Because consider all of these conceptual and technical things that we were just discussing. The current version of ChatGPT, and probably many after it, will not understand all that subtle context, or else it's going to make assumptions for you which you are unaware of. I watched a video today of sort of like how to apply ChatGPT to a Dune dashboard, and the guy was just grabbing code, feeding it to a ChatGPT, grabbing the code that came out and putting it back in. I mean, I get it. It's massively empowering to be able to do something, but you are not really going to understand. There are still at a low level so many subtleties involved. So that's why I'm teaching you this way, where the Chat GPT is an accessory to you doing the real hard work of actually understanding the data properly. The only time that's not going to be true is when you're not going to need to be in the loop is when AI is developed to the point where we can trust it to do all the work. And at that point, we either live in a techno-communist utopia or we've all been turned into paperclips. So anyway, this is why we've been doing it this way. And I promise I haven't been conning you by delaying the talk of actual GPT use up until this point. And I want to start by offering some general thoughts. Now, ChatGPT performs differently for different tasks in different contexts, and in the performance varies in ways that we find puzzling. Right? It seems to massively underperform on some tasks we find obviously and naturally intuitive. I find all these images horrible, and but at the same time, it seems to excel spectacularly at others that we, as humans, find intuitively hard. In the day zero preparation materials, I shared a video by Grant Sanderson, this masterful math YouTuber, and he explains in a technical but accessible way how ChatGPTs, at the end of the day, are really just a sophisticated engine for predicting what comes next. They are entirely built on correlations, or mostly foundationally. I don't know. That's the way it looks like. Now, human language is inherently vague and context dependent. In our scientific era, that's made it a target for criticism, but actually that gives it lots of useful properties in normal human situations, such as tolerance, flexibility, the ability to perform dimensional reduction, useful redundancy. Now, coding languages, however, are designed and engineered as instruments of control, and the ideal properties for such instruments push them towards being suitably exact and precise. And so, when we use our human language to discuss coding problems, that compels us to use our language in a more precise and exact capacity as well. And so it follows that we should expect that a given standard of GPT performance will be achieved more easily for coding tasks than for openly creative, highly context-laden ones. And anyway, these are more than sort of passing philosophical reflections. They help give us an outline to set for some practical guidance of working with ChatGPT on coding tasks. The end goal that we want to achieve in these problems is inherently precise and benefits from being expressed in a coding language that itself has high precision. And so it is not as hard to specify the human language directions that are precise enough to determine the correct end result by way of a GPT's probabilistic engine. So working with ChatGPT reliably in a coding context requires you to say, enough, clearly, and precisely to get your end result. And doing so efficiently involves working out where that sweet spot is before you start, over specifying your prompt. So how do we do this? We start by planning our query. Think of this as being like cooking. We choose the dish we want to create and then plan back to the ingredients and the process that we need to make it. In our terms, we need to start off by identifying the end output desired, which variables are needed, and in which tables are they found, what operations we need to derive these end variables, and is the output time, think whether the output's time dependent, what is the date field and what format is it in, what increments, is a join required, which fields do we use to join our tables, and does the data limit our ability to derive our desired end output? And if so, we need to start over to, think about conclusions or outputs that we can actually derive with what we have, or where to go to get the missing parts for what we want. For simple tasks, this process is something that you can do entirely in your head. But as it gets more complicated, yes, a pen and paper or a digital doc of some kind will help you think through this task more carefully. I call this query planning because it's exactly the same process that you would undergo if you were going to plan a query that you would write for yourself. So once you've gotten your plan, you process it into a ChatGPT prompt. I haven't spent ages working out all the ways you can prompt, but this is what's worked for me. Step 0, prompt ChatGPT to become a Trino SQL expert. And you do this only at the initiation of the memory session. And the way we reason about this step is that it puts ChatGPT into a region of its context space where it is likelier to make associations that are aligned with our intentions. I suspect that the engineers at OpenAI are working to make this step redundant, but I'm keeping it in there for now. Choose a table to start your prompt with, and I guess it makes sense to choose the table that has the most sort of critical data for your operation. Tell GPT its name, describe its context, name the fields that are relevant to your result. Repeat for any additional tables. If joins are needed, specify the names of the joining fields and which fields they join to in the other tables, because remember, they may have different names in the different tables. And if you feel confident, specify the technical type of join you need, inner, outer, left, right, or else in human language, just the desired results of that join. All the mutually matching results from 2 tables is the human way of talking about an inner join, right? As an example. And then finally, instruct ChatGPT to create the Trino SQL code that generates the end result using all the resources you've just specified above. I think that this prompt structure helps us to be precise and clinical in setting out the problem at hand. For all the reasons that we've just been discussing, this helps to reduce the ambiguity that the prompt and of the prompt, and improves the likelihood that you're going to get the answer that you really want. Okay, let's translate that into a slightly more concrete example. I would put into ChatGPT, please assume the role of an expert in Trino SQL. I have a table called table. Every record in this table represents a something. The table has a field called something, which contains a timestamp for every record. Please generate Trino SQL code, which would return a table with a field that has A, that has B, that has C, and any information on aggregations or filtering or scoping that you're applying to this query. Okay, we'll actually see a completed version of that, don't worry. So it'll become less abstract still. And that it doesn't end there. We need to check what ChatGPT sends back. Best way to do that is to read the code. That can be all you need to do for simple tasks. The other thing you can do is critically assess the query's output. And if you have any other data or results that you already trust, compare it to them to check. You could also send the code to a different instance of memory instance of ChatGPT to see if it describes it in the way you've intuited. But actually, almost always you get code back with an explanation of the code. So that also may provide you with some guidance. And finally, you can also regenerate the code, the prompt in a new memory instance to double check. You've also got features like you can use ChatGPT to debug. So if Dune throws out an error, you can put in your code, say, this is my code, I got back this error, you copy and paste the error from Dune and ask ChatGPT, and it usually comes up with constructive advice. It's been a godsend. And you can also use it to add in comments and annotation if you haven't been doing that for yourself. Although, seeing as you'll have a lot more knowledge about what the smart, what the data is, you're probably going to write better comments than ChatGPT will. Although it was funny, at one point, I hadn't told ChatGPT that I was working with token and on-chain data, and it worked that out for itself. So you never know, you may be pleasantly surprised. Okay, we're gonna start on giving you a direction on the homework and the questions preview. So first, create an account on Dune or log in. I've got a URL. I need to finish putting this document together. It's going to go out 1 or 2 hours after this live session. But you can create a team on Dune, and I can send. I have the ability to send out link, which allows anybody who has the link to join for 48 hours. So that will be on the formal homework doc when it's sent out. And work through all the questions on the homework doc, and then display them in the same order on a Dune dashboard. So you're going to be creating your own Dune dashboards for this homework. And the work must be completed before the start of the next lecture, so before 1:30 p.m. on June the 6th, in order to be eligible for assessment. We are going to walk through some of the features of how we set up charts from our data on Dune. But we're not going to cover absolutely everything. So these are references on Dune's official documentation that you can read up to look over all the details. And frankly, the features are not that complex, and they're generally very accessible and intuitive. So you will be able to get rolling very easily just by working it out on your own. And these reading the docs will just sort of like be icing on the cake for your understanding and learning how to do cool little nifty things. Okay, well, it's getting real now. This is a demo of the first question on your homework. I am going to show you a solution here, but it's going to be up to you to recreate this for yourself in all the ways we've been showing you. So this question is: create a bar chart of the total number of swaps executed on all Uniswap v2 liquidity pools, and on that same chart, overlay a line chart which records the cumulative number of swaps on the right axis. Do this for all available data up to and including May the 31st of 2024. Okay, so going back to the playbook we were just talking about, first thing we need to do is planning. And I don't know how many participants we have here today, but does anyone want to have a go volunteering which table we want to, sorry, actually, first of all, it's which output we want here. So it's already stated in the question.
Let's give it a shot. Someone volunteering?
All right,
Raise your hand. Yeah, let's try.
If anyone wants to, and do step 1 and step 2, not just which output, but which variables and which tables might we look at in order to find this result that we want. So steps 1 and 2.
You can also drop a note to the chat. Let's give it a moment. Let's do the planning steps. Identify the output and which variables do we need and what tables.
So, okay. All right, I'm going to have to drive.
Tiago dropped a note.
Okay, we got one.
So, factory?
No. So the questions in the, anyway, this is why I set the homework up. Create a bar chart for the total number of swaps. Okay, so we have in our decoded tables, we have the factory contract, but the factory contract does one thing, right? It creates pools. What's the decoded table that tracks swaps? It's the swap event of the pair contract, right? So that's the table we want, and in that table exists to record events, and every event is a swap. So the only thing we need to do is count the number of swaps, count the number of rows, and we've counted the number of swaps. Okay. So let's see, going back into the format. So
yeah, Nati dropped a note, the swaps. So feel free to switch on your mic and yeah, just fill the first two lines. Let's together.
Yeah.
Nati, if you like.
I think we got there though.
I was not able to do the homework. Sorry about that. I'm a bit behind everything, so I'm watching and listening to you and using my thinking in loud voice, following what you are saying. Yeah.
But that's brilliant. That's brilliant. That's why we step through things very carefully. But you're right. Yeah. So it's the swaps table, and we want to tally swaps. So we look to the swaps table. And I just started going through step 3 when I said what operations are needed. And I said that every row in the swap table, is a record of an individual swap event. So if we want to come up with totals, what kind of operations can we apply in order to? Yeah. So Adith says sum, but actually, if we we don't have a sum is an operator that applies to a numeric value, and we don't have any numeric values in the fields which would tally to give us the sum. So what we actually use is the count function, because we leverage the fact that every row is a swap event. So we know implicitly that every row has a count or value of 1. So we wouldn't. So I got Art suggesting that we sum the TX hashes. That wouldn't work because we have to think about the variable type, and TX hash is coded as a var binary value. So that's going to be like the string which has 0x and a bunch of stuff after it. So we can't sum them. That wouldn't give us a number. I'm not even sure if they're meant to represent numbers. But if they were numbers, we wouldn't be able to understand them. So the way to get around this is to understand implicitly that the rows represent a single event, and we count the rows. So if we count all the rows in the table, we count all of the swaps that have occurred, right? Okay, we've got another comment here. This is excellent. Okay, Natty has asked, do we need to count in or out to avoid duplication? So every row will have a value recorded for in or out. But that's because every swap has an in and an out. It wouldn't be a swap without a sort of action and reaction, right? But you're not at risk of double counting because that in and out happens in a single row. So it's a single event and it's a single record. But in other contexts, that might be a confusion you fall into. So that's an excellent question. Every single swap has an in and an out. And sometimes it's token 1 going in, and sometimes it's token 1 going out, or sometimes it's, that's why we have 4 of them, because they're 2 tokens and they can go in or out. And that's why we have 4 of those fields in this table. Awesome. Great. This is working, guys. I'm happy. Thank you. I hope it's helpful for you too. Okay. The next step is the output time dependent? So did I specify, let's see. You see, I didn't specify. It is time dependent up until May 31st, but I meant to include a specification. I meant to say monthly. So you see, I tripped up on that. So we would need to specify that we want to report the results monthly up to and including May 31st. And is a join required? Well, in this case, a join is not required because all of our data is in one table. And can we get the output we want from our data? Yes, we can. This is a very simple case. And all the information we need to count the swaps is just in the swaps table. So that's all we need to do. Okay, so let's see. I'm going to do this now. I'm going to create a prompt. I obviously did this earlier, but you can see the logic of what I'm about to do. Can I just confirm you're seeing the ChatGPT window now on the browser?
Yeah, we're seeing
Good.
it.
So here's one I made earlier. Actually, I forgot my golden rule. Please assume the role of a Trino SQL expert. Righty ho, I am now a Trino SQL expert. What do you want to do? Okay, so here we go. Imagine I'm talking to my intern or my senior. I don't know. ChatGPT is basically both. I have a table called Uniswap v2 Ethereum.pair event swap. Every record on the table represents a swap event. The table has a field called event block time, which contains a timestamp of when each event occurs. Please generate the Trino SQL code, which would return a table with a field counting how many pairs are created every month up to and including the 31st of May, 2024, and another field with a cumulative total of, swaps. Which will my grammar. And so let's put that in, fingers crossed. Here's the, gosh, it's crazy. This is the funniest thing ever. Can you imagine showing this to anybody like 5 years ago or something? Well, we all saw it like for the first time 2 years ago. This is crazy to me still. That's very short code, but I'm now going to put it, I'm going to copy this. Actually, no, I'm breaking my rules. I'm doing what everybody does. I'm just going to copy and paste it and go back in. No, let's see what I preach, right? So let's look at what it's come up with here. Select date, trunk, month, event block time is month. This is why I asked you to do your SQL homework. So what this function does, the event block time is recording time right down to the minute or second even. I'm not sure which. And often we're not interested in that. So the instruction we've given ChatGPT is that we want monthly data. So the date trunc function here truncates the date timestamp to a certain interval. So in this case, we're truncating it to month, and we're calling that variable month. And we're doing count. Count star is a wildcard so that it includes everything. So count everything as our monthly swaps. And then for the cumulative total, we are using sum of the count. And then we're using a window function. So because we're doing it on a monthly basis, we're doing it over this monthly interval, and we're defining that as cumulative swaps. So these are the things we're grabbing, and we're grabbing them all from one table, the Uniswap pair event, pair event swap table. And we've also specified with this where clause that the time is less than or equal to the timestamp we provided. And we're grouping our data, we're aggregating our data, rolling it up on a monthly basis, and we're ordering everything by month. So the code, I've just read back that code. That makes complete sense to me. I'm going to copy it. I'm going to go into Dune. I'm going to put it in here. And I'm going to hit run. This is the thing with queries. You have to be patient, and when you run a long one, you better have another computer or really like coffee. And we've got the results. We don't know if they're right, of course, but we've got some results. Now, what we can do here, the instruction, the homework asked us to create a visualization from this data. It's data. We're human beings, not machines. So we need everything drawn out and turned into pretty pictures. So we click on New Visualization. Bar chart is good. That's one of the series we wanted to visualize. And there is plop. it's made an intelligent guess that in the X column, I want month, and in the Y column, I want monthly swaps. I can give this chart a title. Well, hold on, let's hold off first. We also want that second series, right? We want the cumulative value. So in Y2 column, I can click down, put in cumulative swaps. That's a very large number. So we want to do two things. We want to display that on a separate Y-axis and display it as a Y chart, as a line chart. To go and display it as a line chart, I scroll to the bottom and set this as a line. I don't know. There we go. Okay, sorry. Line. So that's now a line. And now we want to set this on its separate axis. So we click here on enable right Y-axis. And what's happened? Oh, I also need to specify down here. So I switch it to line, and then in Y-axis, I click right. And now that's looking reasonable. So this is the result. And I can give this a title here, total monthly cumulative swaps on Uniswap v2. Isn't that amazing? Like, we spent, I mean, this is a short piece of code, I understand, but we just put some instructions into ChatGPT and we got all of this out and in very short order and very securely. So this is, it's definitely really special. Now, I want to show you a couple of things here yeah. So I want to show you an extension. What we've done here, it's not in the homework question, but I think this is a really cool feature to acquaint you with. Let me just set up my notes so that I do everything correctly. Now, what we've got here is we've pulled all the swaps for all of the Uniswap v2 tables. And that's great, but sometimes we're just interested in the activity for a single swap, right? So what we can do is use something called what is it called? I don't know. We can create custom parameters that display in our web app area. So I'm going to add a CTE, and I tried to see if there was a way to get ChatGPT to do this. But there are just too many sort of special things going on for that to work. So I've created a separate query here, a CTE, called filtered swaps. And from filtered swaps, what filtered swaps does is it selects everything from the Uniswap table. However, but it adds a filter. So when some value is equal to a special, this string, we're going to ignore, we're not going to apply any filtering, and otherwise we're going to apply the contract address we supply. So actually, what we have here is a variable which I've called pull address filter, and I've wrapped that in 2 curly brackets. And what that does is it makes this guy pop up here in the web app interface, okay? So this is a custom variable. I can put text in here, and that text is then going to go into the query and allow us to do things with it. But I need to continue setting it up. So for technical reasons, I need to set a default value equal to, sorry, where's the default value? Equal to the kind of format that our AMM pool strings are in, okay? So it automatically will type that as a var binary type. And then what we can do is, let's see if this works. So now if I run this, hold on, I also need to change the reference. So I've called this filtered swaps. And now I want to set that as the reference, okay? So I'm going to call this filtered swaps. And if I run this, hopefully everything's okay. We need to wait.
While we are waiting, Nati dropped another question to the chat on the burning address.
Oh, it may be the burning address. So yeah, I forgot which one was the burning address. But in the context we're designing this dashboard for, where we're creating it to either search for a specific pool or return all values, that's okay, right? So if this is the burning address, then it doesn't matter, because the handle we've created here is to default to returning the total for all pools. So that's working. And if I go to Uniswap v2 browser, I forgot to set this up. So Uniswap has recently upgraded its app. Where do I get the app pool? It used to be easier, I think, to actually find pools, but certainly Uniswap v2 pools. So I'm going to go in for USDC, and I'm going to look for tokens USDC. This is because the thing is, this is now showing us the contract for the USDC pair on Uniswap v3, and I want the Uniswap v2 contract. There we go, pools. And if we look here, this one is v2. It has v2, so I'm going to click into it. And this is where I can get the address. So I can copy that address, feed it into my custom parameter here. And now if I rerun the query, moment of truth, I get the results just for the Uniswap v2 pool. So this kind of flexibility is really handy if you want to, just create some more flexibility for your queries and make them more interactive. Another thing I could do is create, so I'm going to do it bit by bit here. I'm going to create a custom parameter for interval. So now I'm going to call, and you see that's popped up another one called interval. And I'm going to define this as a list, which can only take 3 values. It can only take day, month, or year. Okay. And I'm going to call this, so date trunk. I'm going to wrap this here. This one is going to change as well. And this one's going to change as well. And interval, I'm just going to call that swaps, cumulative swaps, filtered swaps. Oh no, this needs to be called interval. Okay, and I'm going to set the default value to month. But I'm now going to load this up with year. And if I run this again, order by interval, because I changed the name of that column, so I have to update that as well. Missing x-axis because I've now changed the name of the axis. So this is now interval. This is now swaps. And you can see I've got it again now. I've got the same chart now on an annual basis. And it looks really cool when I load it up on day. Run, away it goes. So this is a really cool way of adding some flexibility. And you saw that all I did was define a custom parameter with these double curly brackets, and then I go in there to define some sort of properties about that parameter. And this is where you get the cool Uber finance, sort of like everything super sharp and detailed kind of chart coming out. So I still find that very impressive, as you can see. Okay, so that's
Sorry, there was one more comment.
Sure.
Adit, you just added a recommendation for finding pool IDs. You'd like to switch on your mic?
Oh, please, yeah.
No, I just mentioned deck screener, where you can find all the decks, pools, and all the details from there. So I usually use that for finding it, but you can find all the details in there also.
Thank you so much. Yeah, it used to be easy, so I really appreciate having another resource. Thank you so much. Okay, so let's work through number 2. Sorry, I'm losing track with all of these windows. I think I went out of the presentation. So demo Q2, create a bar chart that displays the proportional share of the top 10 most popular liquidity pair tokens used for Uniswap V2 pools. I probably could have phrased that better. The top 10 most popular tokens used as liquidity pairs for Uniswap V2 pools. Do this for all available data up to the end of 2023. So this ties into that conversation I was saying, that there's certain tokens that end up being pairs more often than not. So why don't we look for the top 10 and see what kind of share they have? So what are we... This time, do people want to have a go again and see whether they can think of, first of all, steps 1 and 2, what we want and which tables we need to look for to help us create, get our results. Tiago, this is your time to shine.
And there are so many more in the call. So feel free to drop a note in the chat.
Okay, this time we're talking, remember the pair is something that's defined when the pool is created, right? So that's going to be information that's most efficiently found in the factory contract, in the pair created event. And what we need to do in order to find the most common ones, we're going to have to look up the tokens in token 0 and token 1. Because remember, which token ends up in 1 or 0 is arbitrary. It depends on sort of like its sort value, where it happens to be in, for that given pair. In this case, we don't need a join because it's all in the factory table. And we get to step 6, and I think we feel comfortable that we can get all of that data out. So let's go back into ChatGPT. Where is my ChatGPT window? And now this time I'm going to set very similar instructions. It's going to be very similar. Okay. I've already told ChatGPT I want it to be a Trino expert, a Trino SQL expert. So, dear ChatGPT, I have a table called Uniswap Ethereum.factory event pair created. Every record on the table represents a pair created event. The table has a field called event block time, which represents, which contains a timestamp of all the of when each event occurs. That's actually not relevant. I don't, because we're not, are we? Oh yeah, we're going to sort this by year. Each time has a pair created. Each time a pair is created, a unique pair of token addresses are logged in the table columns token 1 and token 0. And I need to complete this. Oh, I do. Okay. Please, I see. Sorry, I forgot my own planning for this. So the final instruction is please generate the Trino SQL code, which would return a table with the top 10 tokens created in each calendar year up to and including 2023. Okay, so we're going to put that in.
Roderick, can we add a clarification here? Because I'm struggling with it as well. And there was a question in the chat. How do you define most popular?
Most popular, just by frequency.
And does
the number of times.
Okay, and I mean, how do you clarify, or did you clarify with ChatGPT or let you interpret? And
which
in the prompt?
Let's see. In the prompt, yeah, which would return a table with the top 10 tokens.
Top 10.
So that is a clear. That is a clear instruction. Thank you.
Okay.
Oh, okay. This is okay with token counts. Okay, it's interesting. It's given me a more verbose code than it did the first time I put this in. So the what you get does change. Okay, this is really interesting. It's done something much more complicated than it needs to. token counts, select date format as year, token as token, count as count from Uniswap v2. Okay, so what it's done here is it's created a couple of mini tables. It's picking out the date, it's picking up token, it's giving us the count, and why is it doing it this way? Oh my goodness. This is really tricky. I wasn't expecting this. I got a much easier version back. So I'm not entirely sure this is going to work. I'm going to try it. I'm going to try it again just to see. It's giving me a very similar sort of thing. Okay, this looks like it's going to work. I can see this more. So it's created two mini tables. What it's done is it's calculated totals for token 0 and token 1, and then it's applying a union to both of those to kind of like stick those strips together, stick those tables together, and then it's calculating the ranks and returning the rank table from that. So it's really funny. Like first time I did it, I got something really elegant and simple back. But it goes to show, it does sometimes like go on its own trail. So I'm going to put that into a new Dune query. Okay, we've got something back. New visualization, bar chart, and on total creations, and it looks like it's given us a and if we do a group by here, group by token, it should give us a breakout, and then we can go to enable stacking and normalize to percentage, and this gives us the percentages of each. And you can see that one is dominating all of the others. And does anyone have want to hazard a guess as to what that token is? It's wrapped ETH. So this has such a huge effect that we can't see the others. So one of the things we might do with our query is alter it to strip out, to ignore ETH. But it's kind of cumbersome to do this using addresses alone. So actually, we're going to modify our query to also add in the information from the token ERC table, which contains the symbols, so that we can report this chart in symbols instead of all these addresses, which we can't read. So let's go back to the ChatGPT window, and I'm going to modify the query. So it starts out just as before. And I'm going to add this bit. The token addresses have matched symbols which are stored in another table called tokens ERC20. The matching token address is stored in a column called contract address, and the symbol is stored in a column called symbol. And then please generate. I'm going to put in I'm going to put in the top 5 tokens because it actually still ends up being quite cluttered with 10. Please generate the Trino SQL code, which would return a table with the top 5 tokens, which do not have the symbol wrapped ETH that are created in each calendar year, along with their symbols up to and including 2023. So let's put that in. Okay, So it's done something very simple here. It's unioned these two tables again, looking at the token 0 column, the token 1 column. We're pulling the we're doing a join with tokens ERC20, and we're filtering for the symbol not being equal to WETH, and then we're ranking that filtered table, and then we're pulling the results into the final query. Okay, so that all looks pretty sensible. And let's put it in here. Almost there, everybody.
Some comments in the chat around how to force ChatGPT to come up with with shorter and more elegant code. We'll be happy to see your approaches in the submissions, I guess, or
The only way is to do it manually.
Yeah,
I guess that's, last time it was when I did this by myself, it was more efficient. And yeah, sometimes I remember that, my analog was, as an Excel user, there were these things you could do to record your actions in Excel and have them reported in VBA code. And it always did that in a really ugly, verbose way. But that was still the way to learn, right? So, I'm offering this to people as a way to help them get started. But if you already have that knowledge of how you can get the same result elegantly, then do that. And nobody says that this is the only way you have to work with ChatGPT. You don't have to give ChatGPT the entire query. What will happen is that there'll be some task that is, just either a little tricky, but it's quite narrow. And you'll say, hey, I really want to, multiply these arrays in reverse order. I want to start from the back and want to start going from the front, or something, and you're just really tired and you don't quite have the space for that. So you just ask ChatGPT and it gives you that little snippet of code back. I'm trying to do this sort of like grand all-encompassing exercise here to show you how much you can do, but you will probably settle out at that level where you ask it to do smaller, more specific tasks. So creation count, and we're grouping by token, and here we go. Oh no, what do we want? Group by? No, we want to group by symbol. Okay, so, and here we go. And this is interesting, right? So USDC was really big in 2022, and then suddenly it shrinks in 2023. So we're getting some kind of story here that lines up with what we know about real-world events. And look at this. SHIB is now one of the top 5 liquidity pairs in 2023, or it was in 2023. So you're getting insights without much effort here, and yeah. So we're coming to the end. I know maybe that wasn't as interactive as we might have hoped, but what we can do now is, I'm going to save this. Save this query as Q2 demo 2, and I'm going to save this query as Q1 demo 2. And then I'm going to go back into library, and then I am going to go to dashboards. Okay, no dashboards yet. Okay, let's create a new one. And I'm going to call this, say, TA Analytics 2024 demo. And save and open. This dashboard is empty, so I go up here to edit, and this opens up a slightly new set of options, and I can go to add visualize. Well, first of all, I can add text widget, explain your chart dashboard here, And there's some markdown supported. So this tells you what to do if you want bold, italic, if you want a link, an image, and so on. So I'm going to put that in. I'm going to save. And it's a very simple click and drag interface. It locks into an invisible grid. And then add visualization. Okay, here we go. Queries, TA, demo 2, query. So here you can either pull in the query results, which will pull in the table, or the chart. Okay, if you've labeled these differently, they should show up differently. So I'm going to put this up here. And it just takes a little moment to think. And I'm going to put this one in as well. Okay, done. And these are loading. And oh, what's going on? So I when I brought in the other one, it has these custom variables. So those came in along with the query, and I might have to refresh them, refresh the query in order to get them to actualize. So see, I can click run. This runs all 2 queries. Yes, run all 2 queries. And hopefully that loads up the chart we had on there. So that's going to be the process which you go through to create your Dune dashboard. Like it's really simple. It's done to make it maximally easy. There's some cool features here. You can link this to a GitHub page. You can share it in other ways. No core features that we need to bother ourselves with. But yeah, that is how we create a Dune dashboard. And I believe, let me just check. Oops, where is, okay. I'm just trying to get the last one. Yeah, guys, that is officially the end of the presentation. So I want to turn it over to you guys to see if you have other questions.
Yeah, feel free to switch on your mic. And could you link the Dune Strack group for sure? So we'll share all the links that you now need to the slides, to the recording, and also to the homework submissions. We'll go over all the resources needed so that you know exactly what to do and submit by June 6th. We'll share the timeline again so that you won't miss it. Just want to triple check we have all the correct links so that we don't send you to the wrong place.
Any other
Anything
questions
else?
about anything conceptually or anything about the tables? Obviously, you're going to get the slides which have all of that information, so you can look through that, in your own time as you work through this, and that will help you. Having a printout or having that in view will help you think through these steps in the systematic way I recommend that you do.
Roderick, how many questions will we have in the final submission?
I mean, how are people feeling? I was sort of like thinking of maybe 12 or 14 sort of like queries. That didn't feel. I don't know. Like I'm trying to take the temperature of the room here. How do people feel about that?
This is almost an invitation to vote on less, but no. Give us a feeling. I think. I mean, can be pretty quick. Dune dashboard, yeah, as you demoed, is pretty straightforward. Keep a round figure, 10. I did, okay. Less is better, yeah, I agree.
Okay, 10 it is then. We voted
Okay.
on 10, everybody. Okay. Wonderful. Okay, so do we have any other questions or comments, everybody? Otherwise, it's time to wrap up for today, and I'll check in for the final session.
Okay. Keep in mind, we are on Discord, and the submission details will be shared on Notion. So check it in the next hours to find the submission tasks and deadlines published there. Victor, you have a question.
Yeah, just very quickly, because you mentioned it before, Roderick, that I think you said that because of that issue with the decimals, that you basically somehow have to transform. So after the division, transform the value into some kind of other data type, so that you can cast it somehow with the SQL. If I understood that right, is that because I think I've run into this issue before, and somehow magically ChatGPT solved it for me. But it's kind of funny that you mentioned it. So can you just elaborate on it, if I understood that correctly?
Yeah.
Or maybe I got it wrong.
Sure. So ChatGPT will sometimes understands that you're working with this data, and it may have an understanding, it may have like associations that the data is typed as an integer, and it will provide the fix for you. But basically, in most versions of SQL, well, let's take a step back. When you're working with relational databases, or I mean, just in programming in general, you're often working with typed variables, right? Your variables have a data type, and data types are designed to allocate a certain amount of memory to represent the data that you want to be stored in there, and usually also come with certain restrictions on the operations you can perform on the data type. So if you have a string data type, which is the a type that's used to display text, you can't add a T and a Z together as letters. So that operator wouldn't, that wouldn't be allowed. So when you type variables, every variable is like a container, right? So your two considerations are creating restrictions over what you can do with that variable and using the smallest amount of memory possible. So it turns out that to represent a whole number, or very large whole numbers, you need much less memory to do that than to represent very large decimal numbers. Okay. And so it's convenient in many contexts to just type your variable as an integer, and then there are like lots of kinds of integers. And Mark had this great example, which actually I was unaware of. In order to represent the sign of a value, whether it's positive or negative, you have to use up a bit, right? You have to use up one of the values of your ones and noughts. And when you do that, you're halving the amount of data that you're halving the size of the number that you can store in that memory space. So for that reason, a lot of computer code handling works with integers and kind of handles the positiveness or negativeness of the number with a function or with logic that's that goes around that number, right? So anyway, very long preamble to explaining that working with integers is really memory efficient and useful. And so there are lots of reasons why we'll want, those are very important reasons for us to want to type these variables in that format. However, in SQL, every language has its quirks. Like I think Python's very good at retyping things, but in SQL, it just takes the types as they are. And when you divide an integer by another integer, it returns an integer. So whatever part of that division that's in the decimal part gets excluded. And that's not the number we're after, right? So what we need to do is convert the data type into a data type that supports division in SQL. And the function we use to do that is called cast. And, that's like casting the die, casting iron. So we are changing the format, recasting it into a decimal format, or you can use the keyword decimal, or you can use the keyword double. These are just subtle variations that allocate different kinds of amounts of memory to store to the storage available in that variable. So yes, you use cast, cast amount 0 as double, and then as whatever you want to call that variable amount. Like I said, I find it easier because most of the time I'm thinking in human terms. I find it easier to discriminate and label the raw value, the raw solidity value, as _raw. So it's clear when I'm working with those prices and with those numbers. When I'm working with human decimal formats, I'm comfortable just sort of like calling that token 1 or token 0 amount or something. So hopefully that's comprehensive and clear.
Yeah, it's very clear. Thanks a lot. I got it. I think hopefully it's also helpful for everybody else in case it shows up for the homework. So
but that's why I put it in there. And again, I stepped through and maybe it was too much, but you have all of these slides. Just look over them and look at the things that are going to trip you up. I'm aware of them myself, so I'll be mindful of when I throw in a curveball. There are things I'm definitely stepping around in the exercises I've been putting together.
Okay.
Awesome, thank you.
Yeah, thanks, Victor, for the question. And yeah, keep an eye on the Discord and Notion channels. We'll publish the homework and we'll be excited to review the submissions, and we meet next and for the final session this Thursday. Let me check. This coming Thursday, June 6th at 3:30 or 1:30 UTC in the Zoom chat, and for a final round of content on on-chain analytics. Thank you so much, Roderick, for today, and see you all on Thursday.
All right, see everybody. Thank you for your time. Bye-bye.
See you on Thursday. See you on Discord.
The recording has stopped.